Yep.
Yes. Yeah. So the project is funded by the European Union and particularly the North Sea region and the European Regional Development Fund. And the project, as I said, it's called Sullied Sediments, and it's set in the project is sort of then summarized by this image, actually. So what the project is interested in is the health of of inland waterways, such as this river depicted here, the organisms that live in them, and the sediment that's at the bottom of the waterways. So it's represented by this dredger here, pulling out the waterway, pulling up the sediment. It's interested in then analysing doing very detailed lab-based analysis of the sediments in the waterways, and that's represented by this person up here. And so we've got people such as represented here by taking samples of sediment, taking it back to the lab for very detailed analysis. And then we're also interested in how we can, in water treatment, so how we can take the water and the sediment, we can clean it and put it back into the waterways. And then the part of the project that hopefully you can get involved with is represented by these folks down the front here, who are volunteers who are taking samples of the water and then helping us to do a really wide scale measurements of the quality of the waterways. Now, the issues that we're trying to look at are obviously are related to all sorts of pollutants in these waterways, and those pollutants come from a whole variety of sources. So they come from domestic sources. So, for example, this gentleman here is brushing his teeth. Some toothpastes have antibacterial agents in them that then get into the water and then have an effect on the aquatic life in the systems. We've got cleaning products represented by this person over here. Again, they have a whole range of compounds in them, and some of which, when they get into the waterways, are problematic. We have pollutants that come from agriculture that run off into the waterways as well, again, that might cause issues. So the project is all about these different aspects and trying to reduce the amount of water pollutants that gets into the water, but also monitor what's in there and then inform decision making elsewhere. Yep. So that they are better, for the and so ultimately trying to increase the health of the waterways, making them much better place for people to enjoy, but also obviously much more balanced ecosystems as well. So that's sort of the overall aim of the project. And I'm going to talk largely about what we can do as a group to help us with this project. Okay, right. So the project stretches across the North Sea region. It's got 3 main areas where we're working. So the Humber catchment area is where I am. So I'm up here in Hull at the moment. And we've done quite a lot of roll out this system across the Humber catchment region. So this is the whole area where rain that falls in this whole region then flows out through the Humber and out into the sea. We're interested in the Elbe catchment as well, which flows, of course, through Hamburg and out into the sea, and then of course the region that you're in, where the river basin down here, and again this whole catchment area. So we've done quite a lot in here, and what we're trying to do now is roll the program out to these other areas. Excuse me. Yes. Right. So the project ultimately is aimed at looking at a particular class of chemicals called watch list chemicals. So these are compounds that the EU have got their eye on, who are looking at and think that they might be emerging pollutants. So they're looking for ways to monitor these pollutants across EU member states and then assess the risk that they pose to the aquatic environment. Now, those pollutants, those compounds, emerging pollutants, include things like this, lots of names that some of which you may recognize, some of which probably not. So triclosan is this antibacterial that is sometimes found in cleaning products, less so now. Diclofenac is a painkiller. So that causes that disrupts the hormones in aquatic life, so you can end up with fish that have male and female characteristics, for example. You've got the neonicotinoids, so these are pesticides that are used a lot in agriculture. Methocarb, this is something that's commonly found in slug pellets that's used to kill slugs and snails and so on, and this builds up in the food chain. These are antibiotics that also have other effects, including disrupting hormones, endocrine disruptors. And then you've got things like this EE2 or estradiol that you find in contraceptive medication, but also is used to get given to cattle in quite large amounts as well, and so ends up in water systems. And again, it disrupts the hormone balance in aquatic life. So so these are some of the watch lists, but we're also interested in, and as I say, they occur in medication and toothpaste and all sorts of things. But we're also interested in other less emerging pollutants and known pollutants. And one of the main ones that we're interested in is this compound, phosphates. Now, phosphates are a nutrient. So they're an essential nutrient. We and all life needs phosphates to grow. They're used in all sorts of biological molecules. Most obviously, your DNA has a backbone made out of phosphates. So we absolutely need phosphates to survive. And this is why they're also added to why it's used as a fertilizer. But what happens is when these phosphates run off fields, are put on fields, and then they run off the field into waterways, what happens is they fertilize growth of weeds and algae in the waterways, and you end up with this blanket of weed on top of the waterways. So many of you may have seen this sort of thing out in the near fields, etc., where you have waterways completely coated in weed. Now, this is a problem because it blocks out the light, so that no sunlight gets to any plants lower down. But also, when it dies and rots, the rotting process uses oxygen, and so the river becomes deoxygenated. It has less oxygen in it, and that means that the other organisms that live in there can struggle to survive in there as well. So this is why we're also interested in these phosphates, and that's primarily what we're going to be talking about measuring here.